have been organizing this webinar series. So this is a part of nearly 8 different webinars that has been organized through this Coffee Break webinar series, which is running from June to October 2021, covering a wide range of topics, from agroecologies to agrowalk to ontologies. The main idea is to share different experiences of agriculture research and innovation in the IGAD community. So some general housekeeping rules, we'll keep it to 30 minutes time frame for this session. So I will request the presenter to do short overview presentation, maximum 15 minutes, and so we'll then allow some questions and discussions. Participants can type your questions using the chat window, and the speaker will answer the questions after the presentation, or you can raise your hand and we'll provide the opportunity for you to ask your question. So I would like to welcome today's speaker as part of this webinar series, Georgina Cherry from the Veterinary Health Innovation Engine team at the University of Surrey, who is going to present her work on data innovation and semantics are crucial to the future of animal health. So Georgina, I will hand over to you for the presentation. Thank you.
Thank you, Suchif. Okay, can everyone see my screen?
Yes.
And you can hear me?
Yes.
Excellent. Right. Good afternoon and welcome. Today I'm going to talk about the data innovation platforms and why semantics are crucial to data analysis, interoperability, and reuse. As it says, I'm Georgina Cherry and I'm a chartered information professional. I have a master's degree in information science, and I've been employed as an information manager in the higher education, financial services, and digital technology sectors. I started out managing a private information service, but quickly discovered a love of information search and retrieval systems. I spent 9 years as a taxonomist, building data models using text mining techniques. Much of that time was spent at Yale.com. I became a data scientist at the Veterinary Health Innovation Engine, otherwise known as vHive, back in 2019. And vHive is a research center, startup, and incubator that's dedicated to the development and adoption of new digital technologies in animal health. It's located at the University of Surrey School of Veterinary Medicine, which is one of the newest vet schools in the UK. Bringing on to the data side of the presentation. So effective data management will increase the impact of research, and a data management plan is needed throughout the data life cycle, from collection and storage right through to data reuse and archival. Data innovation hubs will facilitate this process. Data sharing is often required by funders for open access publishing. It's also needed for the handover of project data within an organization and for the independent verification of results by peer review. The General Data Protection Regulation requires data subjects to give explicit consent to the processing of personal data. This includes storage, so it's important that any data is anonymized or pseudonymized, and that the minimum is collected for the agreed purpose. Data management, to be effective, relies on the FAIR principles, which I'm sure you've come across. So findable, can others easily find and understand your data? Accessible, do people have to ask you for access to your data? Interoperable, can others open your data files, or do they need expensive software to do so? And finally, reusable, can others reuse your data using your documentation to reproduce and verify your results? So looking at the next step, which is the licensing. So in Europe, copyright is automatic and database right can be claimed over any collected data that took substantial effort to obtain, verify, or present. Copyright and database rights are types of intellectual property rights. Licensing is a way of granting permission and stating explicitly how data can be used by others. There are many types of open data license. Generally, users must give attribution to the data source. They must also publish any derived content or data under the same license, and this is called a share-alike license. Publishers can choose which license to use, and some may actually decide to waive copyright entirely. Data hubs will facilitate this licensing by providing license templates and by enabling users to find and provide data. Governments, companies, individuals, and internet-enabled devices are generating vast quantities of data. These data defy traditional data generation, storage, and processing technology. Data has value only when it's in use, and significant efforts have been made to develop and introduce standards and shared data repositories. Unleashing the full potential of this data will involve data sharing, IT infrastructure, and support services that facilitate data exchange and exploration. New business models will also be needed to make this data sharing viable and sustainable. Data hubs, platforms, and marketplaces will make this a reality. Data hubs provide the ecosystem and governance systems. Data platforms will provide infrastructure that enable data creation, curation, transformation, and exploitation. Data marketplaces offer a one-stop shop where providers and consumers can meet, match, and trade data. There's no common approach, and the best examples of data platforms are the commercial data analytics platforms like Amazon Web Services, Microsoft Azure, Google Cloud Platform, IBM, and Facebook. Data innovation hubs optimize the stages of data preparation, analytics, interaction, and effectuation, as well as managing the knowledge that's gained. Data preparation is a combination of data from different sources into a single platform, and this requires considerable effort, perhaps 80% of the time involved in the full process. So the analysis might only be the next 10%. Data analytics is the transformation of raw data into usable information. Data interactions is how the users interact with the data and generate knowledge. And data effectuation is the use of data analysis to create value in products and services. Data intelligence refers to the management of the emergent knowledge. The current trend is to improve quality of life and animal welfare through data-driven solutions, but there's no single point of access for animal health data. There's a lack of standardized data models and a lack of tools and services to derive insights from the available data. Data sharing is often expensive, inefficient, and legally cumbersome, so many organizations will avoid sharing it altogether. That brings me to our own data innovation hub, DIA. Our vision is to allow seamless data sharing across the animal health value chain. We will enable large, secure, and robust data sets to be accessed and exploited. DIA brings together an ecosystem of data models, data sets, data sharing contracts, and management services into a single platform. It enables the creation and transformation of those data sets, together with the data governance, social interactions, and business processes required to create value-added products from it. DIA is based on current and emerging open standards. It can communicate with internet-enabled devices, run data analytics, and provide data services. It will scale to accommodate big data and increasing numbers of users, data sets, and connected devices. Interoperability is crucial, as many users have existing infrastructure to be integrated with. The platform conforms to security by design principles, including different levels of security, authentication, and data provenance. Privacy by design principles have been implemented to meet European Union regulations. Signed consent will be required from relevant parties covering data reuse and the intended use of any personal data on the platform. Data will be encrypted, and the system architecture will prevent identification or surveillance of users. Robust data governance processes will be applied across the data lifecycle and the user journey. DIA itself provides a single point of access to data relating to the animal health chain. It fosters data-driven research, as well as supporting the rapid development, testing, and piloting of data-driven applications. It respects the legitimate ownership, privacy, and security policies of contributing data owners. The data catalog for DIA uses CCAN, an open source data portal solution to provide data discovery and management services via an application programmer interface or API. The data repository itself has been implemented using Microsoft Azure cloud storage. This storage can be scaled up or down as needed and linked to Microsoft services within organizations. The data is backed up regularly and access is managed centrally. Data analytics and visualization is done through Microsoft Power BI, which enables users to create dashboards based on the data and share them. DIA is a key value-added service to a wider animal health innovation network managed by vHive. There are many different user groups in the network, and all of them will have different requirements as to intellectual property rights, data sharing, and the research questions they need answered. This network will allow vHive to broker relationships between these disparate organizations, facilitate data sharing, and provide data services. Phases 1 and 2 of the DIA project implementation involved a period of rapid experimentation by use case. We created data visualization dashboards to answer specific research questions, and we produced this 10-step process for working with future data partners. The process applies right from finding data through to applying predictive analytics to discover new data insights. Moving on to my own pet topic, semantics is the study of meaning in language. Using a common language, often English, and understanding to describe concepts is crucial if datasets are to be discovered, understood, and ultimately reused. Translation tools can be applied to further support users in generating insights and deriving further value from datasets. Specific keywords and short phrases can be used to label data to make it easier for humans and machines to interpret. Ontologies, which are an interrelated model of concepts and categories describing a specific domain, are often used. Many ontologies exist, and these can be referenced in data projects. DIA's data catalog is underpinned by the DIA taxonomy and metadata schemas. These are based on the datasets available and external sources, including Eurostat, the Animal and Plant Health Agency in the UK, data.gov.uk, Livestock Data for Decisions, and the FAO. The initial phase of taxonomy development used Ranganathan's colon classification system to divide the animal health domain into facets. In colon classification, facets describe the personality or the most specific subject in a domain, as well as the matter, energy, space, and time facets. In a library setting, these facets are generally associated with every item in library stock, and so form a reasonably universal sorting system. Here they're used to make sense of a diverse subject, which in this case is animal health. Taxonomy development was conducted according to these editorial rules. There was a maximum of 4 levels in the hierarchy. Keywords are in English language, and plural form is used throughout to aid keyword interpretation. Synonyms, including other names for the same concept, common misspellings, hyphenated words, and non-natural language terms are recorded. Keywords are in natural language format and in the shortest form possible. For example, we used island and not Island Republic of, or Republic of Ireland. All keywords were in uppercase, and all data sets in the data catalog have been tagged at the lowest level of the taxonomy possible. The initial taxonomy became quite overcomplicated, so I reworked it to reduce the depth of the hierarchy to 3 levels and 7 facets. This grew to 4 levels and 8 facets after I used it to tag a number of open data sets. On the right is a view of the main section of the taxonomy as it exists currently. Initial development was done in Microsoft Excel, and the taxonomy levels could be filtered to show only 1 facet. The bright green highlights newly added or revised terms since the previous edition. Synonyms are in blue, and singular to plural mappings are in light green. In future, I would like these to be generated automatically by a process of keyword normalization. The orange columns to the right are where I began to split the synonyms into broader terms, narrower terms, and related terms if I felt they weren't true synonyms. Managing the taxonomy in Excel became cumbersome, so I investigated VocBench, which is a web-based platform for managing ontologies. My colleague recommended Protégé, which is a free open source ontology editor from Stanford University. After investigating both, we decided to use Protégé, as my colleague had previous experience with it. The benefits of transferring the taxonomy to an editor are that we can use standard World Wide Web Consortium output formats and structures such as the ontology web language, which is known as OWL. And using standard tools makes the DIA ontology more interoperable with external systems. It's also much easier to manage keywords, versions, and reporting if we have a dedicated tool. Progress to date includes mind mapping the existing high-level taxonomy terms. For this, we use Miro. Reworking the taxonomy to fit the Zachman framework, which is a fundamental ontology structure matrix used for enterprise architecture in business, and building ontology classes in Protégé, where we've added relationships between concepts, which are called properties. So as I said before, DIRE aims to be interoperable with external ontologies, data portals, and related data sets. This includes AgriVox Recommender, CGIAR, and the Venom codes. If you're not familiar with them, the Venom codes are produced by the Veterinary Nomenclature Coding Group, and they are used to standardize clinical veterinary terms. I've also been invited to help supporting evidence-based interventions, SEBI, to validate the natural language programming and machine learning tools developed by the Bayes Centre at the University of Edinburgh. The SEBI tagging tool takes livestock documents, extracts keywords and phrases, then links them back to the AgriVoc ontology. vHive are also working with SEBI and others to develop a livestock ontology structure to be integrated into AgriVoc. As I expect, you know, AgriVoc is a multilingual agricultural ontology that's nearly 40, covers 40,000 concepts, and has up to 900,000 terms in 40 languages. It's the preferred keyword source for CGIAR and also for their metadata schemas and their Guardian Global Agriculture Research Data Innovation Acceleration Network. Just to sum up, to succeed, I think agri-semantics will need to be a collaborative effort. We can't really work in silos. It's just not going to be transferable. And also the teams that build these structures need to be multidisciplinary and also use an iterative approach and involve subject domain experts to choose the most appropriate software and other technology to use to verify keywords and information structures created, and to actually test the ontology under normal working conditions, as we need to ensure that it's fit for purpose. I imagine that frequent revisions will be required to keep it up to date, and that sections of ontology structure that are not fit for purpose should be reworked or removed completely. For this, an editorial committee or a working group would be ideal. And that's something that definitely looking to build in with SEBI. So thank you very much for listening. Happy to answer any questions. And also I've put up the link for a open data survey that we're running. So I'd be grateful if anyone that has 7 minutes could complete it. And thank you very much.
Thank you very much, Georgina, for sharing your work. I would like to now open the floor for questions and discussion. So colleagues who are joined today, please either send your questions via the chat window, or better you can let us know if you want to ask your question, and we can make sure you get the opportunity to ask the question. So you can use the raise hand function here, or just let us know if you want to ask any questions to Georgina. In the meanwhile, George, anybody? Hello, Baldisera, do you want to ask a question?
Yes, thank you. Thank you very much, Georgina. This is a very, very interesting presentation. I have a couple of questions. The first one is, so I understand that the data that feed the database are proprietary data, so they're not open. Am I correct?
That is correct, but I have catalogued about 800 open data sets, and I've used that to feed back into the ontology development. So those are open source.
Okay, and my second question, it's a question maybe for myself, if you can answer, would be useful. So I'm working in the plant health sector, and I'm trying to build a node that will reference data sparse throughout different platforms. So your model, it's very nice, and I would like to discuss with you in the next days or week. Do you know if there is already a platform like yours in plant health?
I have come across one. I'm trying to think what it's called. Is Louise still here from SEBI?
Yes, I am.
I'm sure you'll remember better than me.
Platform. Oh, Guardian. There is CGI, but that's a bit different. Yeah.
There's one within it. Is it by Ilri? Because I came across one and thought, oh, this is great for plant health, but I'm looking at livestock. So if I remember, I have to send you it over.
I'll have a think as well, Georgina. Yeah. But yeah, I'm sorry I can't help.
I've definitely seen one.
Okay, in any case, I will send you an email and we can chat.
That would be great.
Yeah, thank you very much.
Thank you. We have one question from Cameron who has asked a very interesting work. How many people are involved in this project?
Within vHive, there's about 5 of us, and we also work with Zoetis, where there's another 3 or so. And then we work with a software development company over in Greece. So there's another 4 people working there. So relatively small. Ontology development, it's mostly myself working with a colleague who is working for University of Exeter in London. So he is working on the project as the business model side, but he's also has experience with ontology development. So both of us are working on the ontology at the moment.
Thank you. Any other questions from colleagues? Please, we have at least 5 minutes more. In the meanwhile, can I also ask, so did I understand correctly? So you are planning to contribute to the agro work at some stage, or are you already contributing?
We're not yet, but we aim to.
You aim to, okay.
I think so much work goes into these things, and they need that external verification that it's a great deliverable to come up with.
Okay, great. Anybody else want to ask any questions to Georgina?
Yeah, I have another question. Between the organizations you work with, I've read that you collaborate with OIE. So within OIE, there is this network of research funders, StarIDAs. So do you collaborate with them? And are you also working on procedures to facilitate the transfer of data produced in the framework of their projects in your database?
That is the aim. At the moment, we're working on database infrastructure.
Yeah.
So we've held off on getting back in touch with OIE, but we do have a contact. We have had conversations with them, and we're both keen to proceed with that.
Thank you.
Thank you. We have a question from Louis Donison, who is asking, does the data drive the scope of the standard terminology needed? Louis is here. Louis.
Yeah, hi. Yeah, I know Georgina very well. Yeah, it was just sort of a question I was sort of curious about. Is it quite iterative that obviously the data is coming in and then you realize it's in a certain domain, and so you realize actually maybe the standard's there? Because that will be very interesting to share with the community how that's evolving.
Yes, absolutely. That's where having those subject experts will be a great help. And also, if we can break down the development into looking at specific use cases. So we're quite a small team. So when we have something new coming in, we have to spend the time to understand that data set. And that does involve that 10-step process and working with veterinary and computer science software experts. So at that point, yes, we need to expand to actually get the terminology. Up to now, I've tried effectively to rein myself in and only describe what we have, because otherwise it's so easy just to go into great depth that you might never need. So it's been quite helpful to rely on that cataloging exercise. So I did get through about 800 data sets from all sorts of places for cattle and poultry, which obviously took a long time, but gave me this great resource that I could then gather terms from.
It's great, thanks.
Thank you very much. So I think we are coming to the end of our presentation. So if anybody has any other questions, feel free to contact Georgina directly, and then you can continue the discussions. I want to thank Georgina for coming and presenting her work today with the IGAD community. So thank you, Georgina. And I also want to thank the IGAD leadership and the colleagues in the IGAD who made this possible. Veronica, Chelsea, Imma, Patricia, and everyone who all make this IGAD webinar series possible. And in fact, there will be one more webinar in October, I understand. So more details will be sent through the IGAD community later as well. So once again, I want to thank Georgina and everyone who joined for today's webinar, and we look forward to seeing you in one of the IGAD meetings or webinars soon as well. So thank you very much. Bye for now.
Thank you.
Bye.
Thank you. Bye. Excellent initiative. Thank you very much.
Thank you. Happy to share presentation, but me adding all the images to it's made it quite large. So if people want it, we'll find a way.
Yeah. Thank you.
Thank you. Bye-bye.
Thank you.
Thank you. Goodbye.